Welcome all to all the BioClues participants for this conversation with me. Incidentally, this is going to be uh, our 40th guest and about 24th conversation. I'm absolutely honored to have Sonika Bhatnagar, who is a professor at Netaji Subhash University of Technology based in Delhi. I mean, to introduce her and her accolades, probably I'll take more than 2.5-3 minutes. It's absolutely a kind of a scintillating thing to introduce Sonika. In fact, I've known her for almost 13-14 years. My first exchange of emails went back way back in I would say way back in 2009, where I had a brief stint in CDAC Pune as a visiting scientist. That was when I probably contacted her. But we have been following wonderful scientific expertise that she brings to the bioinformatics community now and then. But very recently, I met her in NIIT University in Neemrana when Utkarsh organized a conference where she was a speaker. Sonika is a PhD in biophysics from All India Institute of Medical Sciences, and she has had a greatest stint in working for University of Maryland as a mentor, and she also produced as many as 30-40 students, both from the master's, PhD, and as well as postdoctoral level. If you really look back into the Women Scientists Forum in India, we hardly find women bioinformaticists practicing, and I think we are immensely proud today to have Sonika, who is one among those wonderful bioinformatics scientists in India, and who knows, it could even be the world as well. More to that credentials, Sonika is an innocentive awardee, where the Nature Innocentive challenges are released from time to time, and she won several dollar prize where she came up with a wonderful solution. So she is basically a kind of a problem solver. That's how great scientists are. And Sonika is also besides serving as a professor, she also does mentoring on her own, and of course through BioClues as well. And her main interest coalesces both bacteriology and as well as eukaryotic biology, cell physiology. But her more works coalesced on insulin resistance and as well as diabetes, where she successfully came up with wonderful publications to the fore. So thank you so much, Sonika. I'm absolutely delighted, and so are all the BioClues members. We look forward, for your wonderful presentation, which we'll have a quick Q&A session. Thank you so much, Sonika. Please. Yeah.
Thank you, Raj, for the very kind words, and really thanks for inviting me here to talk today. I have been associated with the BioClues community for the past 2 years officially, but unofficially, yes, ever since the beginning. What I've seen is that in the past 2 years through interactions, I really admire the kind of wonderful and enthusiastic community that you have made up. The way you share so much information, knowledge, and we help each other out through WhatsApp groups, and when we celebrate the individual achievements of each of the scientists, that I really admire very much. And this specifically, I feel, is a very nice initiative where you are calling scientists to come and share their experiences on a regular basis. Generally, people feel that scientists are weirdos, that they have their heads up in the cloud and they cannot talk to other people. But you've made science and scientists accessible to everyone, and that I think is really commendable. So kudos to you and your team and entire set of senior and some of our colleagues who are involved with running of BioClues. So I'll start with a little bit about my academic journey, which started at AIIMS. So right from school onwards, my graduation onwards, I moved to AIIMS, where there was a course called BSc Honors in Human Biology. This is for scientists who want to do medical research. It was oriented in such a way that there was a basic component of knowledge about the human physiology, anatomy, and biochemistry, and then look into all the research methodologies in each of the clinical fields, starting from microbiology to pathology to any other kind of clinical reproductive or any kind of clinical field that there is. And then we had an option to specialize in certain areas, of which I chose biophysics. Biophysics for the simple reason because I was very much attracted to physics and to maths right from school. And this gave me a chance to amalgamate both of my interest areas. So as you can see over here, this is AIIMS, and right at the corner over here is the small department of biophysics, nestled under the trees. On the right-hand side here is once when Sir had invited all of his students and colleagues to his home in the AIIMS campus, and we had gathered together for lunch. And this is my mentor, Professor T.P. Singh, whom I joined in PhD, but he was a teacher and a mentor since right from graduation days, since we specialized in biophysics, and he was the head of the department at that time. So my MSc was more towards the theoretical biophysics and computational chemistry side. But for PhD, I joined him for doing protein chemistry as well as structural biology. His was an X-ray crystallographic lab, still is, and very active lab. Professor T.P. Singh is also a very active scientist still. The PhD and postdoc work that I did so I started with protein purification. We were purifying proteins from plant sources, and for various reasons, sometimes the yield was less, and sometimes the protein was unstable or something. I was supposed to do crystallization of the protein. The crystals did not appear. So one has to, under these circumstances, via the PhD coursework, I ended up doing a lot of biophysical and biochemical characterization. So what happened is that during this particular period of time, not only did I learn the ins and outs of experimental biology very thoroughly, but I learned instrumentation, and I found that with each technique that I used, starting from UV to even circular dichroism or any of the other studies, there was a lot of data here in biological sciences. And then there were a particular, I think, software, Accelerus software was launched at that time, and the department purchased it, and I got hands-on on it. So I added some molecular modeling studies to my PhD work as well. So all this came together when I had to make a choice to move for my postdoctoral work. So then I did molecular modeling and rational structure-based drug design in the Department of Biophysics. Then after postdoc, I looked for faculty positions, and I came to NSIT Delhi. At that time, it was Netaji Subhash Institute of Technology. So, they were just planning to launch a biotechnology program. There was no department, no course, no curriculum, no students, nothing. There were 2 faculty members. One was senior. I joined as the junior most faculty member. And in fact, For 2 years, we just kept going through the all the procedures for getting all the approvals for the getting the course started. Because at that time we were with Delhi University, and Delhi University was the academic affiliating body. So during this time, from 2002 onwards, I was continuously thinking how to manage, what research will I do. I was very sure that I wanted to do computational work, but what research would I do and what would I pick up? And so it happened that in 2003, I came across something that seemed to match a challenge, an online thing that seemed to match just what I was looking into. What makes a drug target a target? What makes it suited for targeting in a particular condition like obesity? What are the how to experimentally validate that target, and how to design drugs against that target? And that's what I did. I submitted a challenge online, and honestly, I never expected it to win, but it won. So yeah, in 2003, I was awarded this Innocentive Solver, and I think that really cemented the way I thought about drug targets, and that I was going to work in these drug targets in my later years. Then, in the meantime, in 2004, we had started teaching and taking even project students for this thing our labs had developed. And when you come to NSUT, I can tell you one thing: our student quality is always very good. Sometimes they're not directly interested in biotechnology, but the amount of sheer thinking power and the enthusiasm and the kind of students that I see over here, that's one of the perks of working at NSUT. Again, during this time, I was not just teaching, which is you have to do a lot of teaching in engineering colleges, so preparing notes and all teaching related this thing. I was developing the curriculum and labs, interacting with students, but I was also planning my research work. So in 2010, my senior, he moved off for a sabbatical, and for about 1.5 to 2 years, I just ran the department alone with guest faculty. Of course, you can't do all the teaching yourself. And I had pretty much the burden of the department, but the lucky thing that happened with me over here is that Professor Rakesh Bhatnagar from JNU, he had heard of my work with Innocentive, and he said, okay, we want to do some work for our papers, and he invited me to work with him. Between 2010 and 12, we worked together, and then subsequently we kept working together, produced a number of papers and students together, and I made my own research lab, and we held several conferences, get-togethers together. It was a very interesting and productive time. So during this time, I was constantly thinking, what is exactly, apart from this, what is it that I want to put my technique to use in? And what we came up with and ended up doing over a period of time is that we brought the techniques of computational biology. I think this became because from one of the papers I was reading in Nature said that while the cardiovascular system has been studied extensively from a clinical and microbiological, any other kind of aspect, even experimental aspect, but there is very little systems biology or molecular insight into this system. So that is what we did. I think I'd been looking also at genomics and proteomics resources for quite some time. So we made an integrative biology approach to do systems biology at every level of cardiovascular disease, producing at hyperlipidemia. We looked for drug targets for stopping the progression of hyperlipidemia to associative disease and found lipidomic markers of CVD. Recently, we published a machine learning study for small molecule inhibitors of progression of hyperlipidemia to other complex diseases. Then in atherosclerosis, we studied how that progresses to associated diseases like microvascular eye disease. In cardiac hypertrophy and microvascular disease, also we did similar things like studying the drug targets, selecting them, characterizing them, doing modeling, and doing structure-based drug design for heart failure and associated diseases. In the 2 years, yeah. Is there a question? Shall I go on?
Yeah, no question. Please go ahead, Sonika. Sorry, yeah.
So in the past 2 years, we have shifted our focus slightly in the sense that we were already working on the microbiological effects, the effects on pathogens that lead to heart disease and what are the beneficial and detrimental effects. So we were already looking that, and we had a database already on that. And then we started working on machine learning because there are no drug targets for finding out for stopping the microbiological, the pathogenic effects of microorganisms on heart. So when COVID came, we were just in the right place, and though we did not directly publish on COVID, but we will extend our work to COVID now. So we are working to a large extent in post-pathogen interactions. And that's the area that we are developing these days. Here is, I could not resist, although I know it's not purely a technical talk, but I could not resist. I wanted to show some of the things that we have done, a lipid protein interaction network in hyperlipidemia. This was, though the data was there, had never been done before. This led us to explore the phosphoinositide binding in PH3 domains. Then on the side of cardiac hypertrophy, we found a target that can modulate between pathogenic and non-pathogenic states of cardiac hypertrophy. And we did the modeling as well as intensive simulation studies and then drug design with this molecule, which is like we are taking it further. Then on this side, I'm showing you some bacterial stress response networks that we explored because I wanted to, I had some hypothesis that there were certain central elements in all kinds of bacterial stress responses. And this is something that we are now going to carry on with the MTV. So this was done in E. coli. So this is the range of work, the range of techniques that we have used in computational biology to different types of data. Then in 2017, while we were still with the university, I took over as head of the department. And by this time, instead of 20 students, we had 75. Our faculty strength had grown. There were 6 of us, and 3 emeritus professors are now there. One of the first things that I did after taking over as HOD is look at how students can be motivated to participate, how the interest can be, how the interest can be started up again. And we had a large number of different events. We had foreign delegates speaking. We had alumni coming in to make presentations. And we had poster competitions. And I think we had a very good interaction, which COVID could put a stop to. I was, but we carried on in other ways that we could. Field trips. It was at the same time on the teaching front, we had to consolidate our pre-existing programs, and we started an MTech in bioinformatics with in 2019, which is an interdisciplinary course run together with our computer science department. So we became a university in 2019. So the entire set of academic work had to be done again. We developed our labs from zero to this situation where we have loads of very high-end equipment and laboratory infrastructure. We offer a PhD program also. And for every faculty member, we have separate research labs as well as the common teaching laboratories. So this was more or less about my academic career, and I do other things as well. There are various things that I'm associated with. On Facebook, I maintain an alumni network, which is a very supportive and very empathetic network for students. And this is specific to our biotechnology department. Also in COVID, I think many of us suffered, and our Vice Chancellor, Professor J.P. Saini, initiated a medical center. And this medical center was built with the help of Alumni Association of NSUT. And we now have an oxygen bank that gives out oxygen concentrators free of cost to you, to students to use. So I've been involved with that. I've have it hard, the thing that women need to be encouraged in taking up different entrepreneurship and other activities. So co-organized at AIIMS this event honoring women entrepreneurs. And we are starting together with colleagues all over India. We are starting together, the Biofootprints Foundation is starting a Biofootprints Society for Science Popularization. So these are some of the things that I've been involved in, and very nice sharing with all of you about my situation. Should I stop sharing?
Yeah, it's okay. You can just skip that, Sonika. But that was a fantastic presentation, Sonika. Quite inspiring and an amazing way, to put it in brief. The very first 20 minutes, absolutely, amazing. I mean, to start with, Sonika, I mean, you have had kind of an amazing career, both from the perspective, excuse me.
I could not hear you clearly. Could you repeat?
Yes, I'm sorry, Sonika. Is it clear now? I just muted in all. Yeah. So what I was saying is you have had an amazing career, Sonika. That's quite amazing. I mean, if you really look back over the last 2 decades of your experience, more than 2 decades of your experience, what transpired you to take up bioinformatics? I know in India, whenever we talk about bioinformatics, it's only cheminformatics or computational chemistry, to the fore. But you were something, beyond that. What was the inherent challenges, at the very first instance that you might have really posed, and what made you to take up, bioinformatics?
Like you said, that coming from structural and chemoinformatics, as well as drug design kind of background, informatics does make a lot of sense. But I think at one point it was a lot of exposure to the kind of syllabi we were putting together, and the new technologies that came in the form of genomics and proteomics, and the entire area of genomics, the way it developed, I think it really excited everybody. I was teaching some part of it, and it made me understand the whole field at such depth. And I thought that there should be some way to make it more integrated. There should be a way to integrate various types of data and to come up with novel biological insights. And that is something that I really want to do. And I think that even beyond molecular sciences, we will continue to do that in future.
Wonderfully inserted, Sonika. So, Sonika, when you introduced this bioinformatics curriculum, at that point of time, there was a lot of, enthusiasm budding from All India Council of Technical Education. There were also, a kind of, common bioinformatics curriculum, that was to be started at some point of time. Right. So, did this autonomy from your institute, did it really help you fetch more grants or more number of students than you probably would have been somewhere in a government institute?
We are a government institution, and as a technical institution, we are very strictly governed by AICT. So we have to go by AICT approvals. We have to have the requisite number of AICT faculty as well as students. So last 2 years, we were also involved in the process of NBA accreditation, and we realized how much is expected of us teaching faculty in terms of every type of activity that we do. It has to be done in a certain way, and that is something that is still changing, I think, in India. But our bioinformatics MTech program is somewhat new, and I think COVID came in right in 2019, and then we don't have a lot of individual dedicated funds for our MTech program as of now, but we expect that it will happen sometime soon once we are through with the COVID crisis. But otherwise, there is no dearth of funding for building up the technical education capacity at the level of the university. It's very supportive. My labs and all computers all have been provided by the university. Programs are fully funded by the government, and there are very good financial incentives to students. Although the fees is high, but if you're a good student, you have scholarships, you have fee waiver, you have every imaginable kind of support in terms of infrastructure, financial support, faculty, the kind of work you want to do. So I really feel that this is a very good opportunity that we have created in the field of bioinformatics.
Yeah, wonderful, sir. So moving forward, Sonika, I mean, getting an innocentive award is certainly kind of a dream challenge. It was a kind of never easy thing. Many vying for such solutions, or probably problem solving and all. What was absolutely going through your mind to meet these challenges, that too at the helm of your early career during those days? That's certainly kind of an inspiration. Yeah, thank you so much.
So you know how crowdsourcing works. It depends on the right person with the right idea at the right time, and I suppose that was just me. With my background at AIMS and the kind of things I was looking into. What really excited me about the challenge was the way they had very clearly put down the criteria for demarcating the drug targets to what is it that you wanted to know and how much detail they required. That really, I think it's an art for industry to ask that kind of questions from scientists, and it's an art to ask the question as much as it is an art to answer it. But there's one thing that, like you said, it's a dream. I was not really very aware of this dream when I did InnoCentive. InnoCentive was kind of, nobody knew about it much. But the dream with me has always been that some such kind of platform should be there for industrial problems within India as well. Why don't we have that yet? There should be something like that. Don't you think so?
Very much, Sanika. Well said. I think Indian brethren, Indian bioinformatics community, needed this. I know. I think I would really take this back, to a kind of a mediocre STEM curriculum that probably we have in India. That is really taking these challenges a bit unsacred for us. But I think you have absolutely have a great point on this. But you're always you're also modest in admitting that not many people knew InnoCentive when you cracked it. But InnoCentive at that point of time was suddenly a big thing during those days, and many people vied for that. That's very kind of you. That shows the kind of intelligentsia that you really drived towards it. That's how great scientists are, Sonika. I must admit that. Thank you so much. So Sonika, I mean, I needed to put a kind of a very open and a straightforward question. I know, being a women researcher was a kind of equally challenging, right from granting perspective, taking up the work-life balance, and also taking your scientific community forward. You have wonderfully put up that particular thing over the last 2.5 decades of your career. It is quite a Herculean effort. You've got a wonderful family. You've got a wonderful child who is, I believe, is an MBA graduate. How did this take this? How did the road begin? If you can just please elaborate, please, so that young generation over here would definitely learn from this wonderful work-life balance that they need to apply this strategy. Yeah, thank you.
I think that okay, work-life balance is something that I talk to my children about often, and yeah, you should have a personal life. You should have a professional life, and see, this question you would never ask a man that how do you work while having a family? So I don't want to extrapolate it to myself either. I work, I have a family. That's it goes side by side. There's a personal and a professional life. Like the main challenge for women is in some very critical point of time when they feel that they can no longer work and they stop working. But then now also there are a lot of very good women schemes that support women through those very crucial times. And that if you see the DST, WAS-A, WAS-B schemes are extremely, they're supporting women through those very difficult times that sometimes you do come up with. But there is no reason why a woman can't work or can't do the things that she wants. If you just have to work, you have to do it. You do it, everybody else does it as well. I think one thing that I have seen is that I have a large number of female colleagues at NSUT from whom I have seen and observed that they have handled their lives very well and they are very strong women. I have drawn a lot of inspiration and strength from them. My colleagues in AIMS are doing very good work, and that's how you make the right friends and you look up to the right people and learn from them, move forward.
Yeah, yeah, wonderful, Sanika. Yeah, thank you so much. And I'm sorry, if my question bit offended you, but I would also ask this question, to the gentleman as well, because it's certainly a kind of not an easy task. Of course, the women has a greater advantage. I would say it's. I mean, when I say advantage, greater challenge in narrating down their work-life balance experiences. I know it's certainly a kind of a challenging task.
But since we are both like we work like, I'm sure you have certain challenges too, and you do overcome them too.
Yeah, very much. Yeah, I mean, certainly, Sonika. In fact, of course, now I'm also a bit fortunate that I've got a better half, who would run the show behind, although she's also a researcher. That's the beauty of it. That's how we gentlemen, I feel, we should always be thankful to our spouse. The way that they run the show from behind, and that makes us that they ensure that we sail through the boat. Likewise, we also need to learn that art of engrossing the family, ensuring that the work-life balance is sustained in all through. I know, yeah. So thank you so much, Sonika. So moving further, Sonika, I mean, you have done an amazing work on the diabetes research that you were putting up, a coalescence of diabetes and cardiovascular diseases and all. If you really look back, post-COVID times, I think it has really assured a kind of a need to take care of the health priorities and all these kind of things. So I see that you also run an alumni group. You have helped many COVID bioinformatics researchers or whatever. Where do you see the so-called the diabetes capital of India going through the next probably next decade, especially the post-COVID times, and not just stopping this particular question, but can we really bring the bioinformatics community together in stopping this pandemic phase, especially touching the base of such comorbidities? So where do we see this particular challenge the next decade?
So I think before COVID came, it was not that well realized that comorbidities can have such a huge hand in propelling what is the final stage a disease reaches to in a human system. It's only when we started recording that so many of the COVID deaths were in those people that were having heart problems. Also that so many of the COVID patients developed subsequent heart problems, that this whole thing got highlighted. But complex diseases are, I think, very much we need to look at them in all kinds of theoretical, experimental, and clinical ways. So that because it should not take COVID to highlight this. Complex diseases are there because the human system is one system. Though in modern medicine we treat it as separate specialities, but it is one system, one holistic approach is required, and that can be brought in with the data, all kinds of data, if you integrate it together well enough.
Yeah,
Especially with respect to cardiovascular disease, I will say this, that I felt that I was just doing the right work at the right time. And we have certain things under publication. Do you also find that the turnaround time for reviews is much longer these days? Because I find that, and things are slow.
yeah, yeah. I agree very much, Sonika. I know, peer reviewing is certainly kind of an art, and post COVID times, I can certainly say that it has certainly become a kind of a challenge. And not only that, but keeping in view of the COPE ethics or the Committee on Publication Ethics, ensuring that the authors follow the FAIR guidelines and all these kind of things. This has really become a kind of a challenging task. And of course, the onus is on not just the scientific community, but the peer reviewers as well, to ensure that every paper that we review is passed through these FAIR and COPE guidelines. These play a very important role. Yeah. Moving further, Sonika. Not many women, unfortunately, are not really taking up bioinformatics or even biotechnologies per se. There is a growing demand to ensure that bioinformatics can really bridge that particular gap, where we can en masse have a good number of women bioinformaticists. And I'm sure post COVID, I think since many would probably work virtually, we can take this particular opportunity where we can bring women in bioinformatics as a greater dream. So where do you see this particular challenge taking up probably the next 5 years, Sonika? Do you have any thoughts on this? Yeah.
I think many IT professionals are working from home. And I also feel that it's not a long time now that the COVID situation will tide over. So looking beyond the COVID situation also, I would say that I find a lot of very amazing and talented women coders, our own students who they learn on their own and they come and they do work with us in our labs. So this, right from the beginning, I had this very interesting thought that given the kind of talent that we have in NSUT, we should involve the undergraduate students in our research, and we should give them a chance to be associated with the PhD students and to make a contribution and to publish with us and do some substantial work so that they feel interested in the subject, they feel rewarded, and they go on to higher education on the basis of what they have done. And many of our students have done that. Both girls and boys, the undergraduate students, have worked with us on bioinformatics projects, have done very well indeed. I think that way the bioinformatics program eligibility that we have crafted is also very interesting, in the sense that we'll take any students from a BTech computer science background, as well as the BTech chemistry background, as well as the BTech biotechnology background, because the other things that you need to teach, you can teach, but that specific specialization and the hoard of expertise that you bring, the knowledge that you bring in from another field, that is what this kind of an interdisciplinary field needs at the moment. And at present in our bioinformatics program, we have a large number of girls and some boys also. Our topper is a girl. She is very much interested in biotechnology. She is going to make her mark in bioinformatics too. So we look forward to this program succeeding.
Right, wonderful, and that's quite amazing and inspirational. I mean, that's quite great, Sonika. Sonika, I mean, moving further, more towards academics, and if you really see, as we were discussing that India has seen more number of chemoinformaticists or more number of chemists taking up bioinformatics right from its inception in 1995. But ever since, somehow at some point of time, we always I wouldn't say we failed, but we always had a fallacy in not bringing any drugs to the market from our computer aided drug designing. I mean, we have invested hugely on such drug repurposing or drug designing softwares or the kind of tools that we have developed. Many of our publications go hand in hand through docking and simulations, and yet if you really look at Indian map, at least Indian authors in India are always shy at this particular things, bringing any such markets, the drug markets from docking at least. But nevertheless, if you really look back, there are many other Indians who are outside India who didn't probably shy away in bringing such wonderful drug repurposing or drug dockable complexes to the market. So where and why with all, we are really failing in India? Where do you see this particular challenge in India? Can you please, elaborate?
Very interesting question that you have asked. Actually, this is something that I'm writing about currently, and you'll see something about this from me soon. So if you look at a study of all the Indian drug companies, all the top Indian drug brands, over the past 20-25 years, starting from 80s, where India found its first drug and it became a blockbuster drug, and drug design was supposed to be the next big thing in India. After that, if you see that, then each of the drug companies closed down their R&D operations, the in-house R&D operations, and they no longer do drug research. One, because generics are much more profitable business. Second, because the most of the pipeline, most of the small molecules that were there, they failed in the preclinical phase. That means that they did not really cross over to the clinical studies at all. And therefore, after a period of time, because if your drug fails in the preclinical phase and you are not able to move ahead, that means that for the company, that it is easier. Right now, the contract research drug R&D is really doing very well in India. The drug discovery contract services are doing extremely well. They are outsourced to other companies. It means that there is a flaw in the pipeline because it does not let the drugs proceed beyond a certain point. One flaw could be that the targets we have is not well enough chosen. Then another flaw could be that the compounds that we have are not doing well enough. But instead of sinking that boat, because we know that other people are able to do it and can do it, we should work more extensively at pinpointing the problem and solving it.
Yeah,
that was my analysis from what I have read so far.
Yeah, I completely agree, Sonika. I think team building and the willingness to collaborate rather compete plays a very important role towards this juncture. I think you have wonderfully put that particular thing. So Sonika, I think you have produced wonderful PhD fellows and you have executed wonderful projects. Uh, what has been your biggest, what do you call, project that you could really think that has really shaped the bioinformatics community, or which is pretty close to your heart? Whenever you talk about projects or about your students or anything that you really wish to, express. Yeah.
Okay. If you really ask me, then I do feel that I've seen this field grow. I've been part of it, and there is still a lot more to do over here. The techniques and computational approaches that we use change every year with every student. They specialize in something. They pick up new techniques, and we learn how to apply them. So when we picked up machine learning about 2 years back, we did not know how it's going to be translated into biological drug target selection. But I have put up a manuscript that currently we are reporting a technique that selects drug target with in pathogens with an efficacy of 99%. So I'm excited about that work, but otherwise I feel I've been very enthusiastic and excited about each and everything that I have done. Overall, I think that with our work, we have brought a new computational approach to the cardiovascular system. We have made contributions to drug design against protein-protein interactions. We've shown that it works in bacterial systems. So that's work that I'm very proud to have been involved with.
Wonderful, wonderful, Sonika. To move further, I think one of my, I always, been intrigued with your systems biology approaches. That's quite phenomenal and amazing. One of the foremost things that I always thought was in India, so if you really talk about the lifestyle diseases like diabetes, with due respect to the researchers or to the scientific community, the Jivas based studies have really been a kind of not so promising strategy, because we would only probably end up identifying the allele frequencies that are not really countable, that would really correlate or that would not really correlate with the diseased condition or diseased phenotype. And this also applies the same with with the cardiovascular diseases as well. The many Jivas based studies, many Indian researchers have really taken up these Jivas based studies, but we haven't really escalated this cardiovascular disease based Jivas to FIVAS, which is a phenotype wide association studies, or maybe further moving towards the exome based or the NGS based strategies. What has been the lacunus so far in this particular approach, Sonika? Is this a kind of a limiting step that is probably allowing us not to identify plausible markers towards the systems genomics in cardiovascular diseases? Or probably we're not really looking forward towards that. Maybe we are not yet really prepared towards that particular strategy, keeping the diabetes as one of those things behind. Can you please elaborate? Yeah.
So I think one of the lacunae that one should really look at in Indian academia and industrial scene as a whole is that there is not enough collaboration. And till the two parties collaborate towards a certain common goal and move towards that certain common goal with a product in mind, till then, I think that we will, starting with some technology or the other, we'll keep having one or the other problem. we have used GWAS in some of our studies. In other studies, we have not, we've used other kind of data. From a bioinformatician's point of view, we uh, we feel that the more the kinds of data and the more the statistical robustness of that data, the more the less the experimental error that comes into play. And the experimental error is eliminated to some extent, and the more important things come to fore because of the statistical robustness of the treatment of the data. So more of the techniques will keep changing and more of it will keep coming in. Like genomics has changed completely from the way it was done before, and such exciting things are happening. So I think more and more data sources are going to keep coming in.
Yeah. Yeah, wonderful, Sonika. I agree. You always speak about positivity. That's the greatness, Sonika. Of all the questions that we have had, I didn't really find any kind of a pessimistic composition that you have narrated. That speaks, the wonderful positive vibes that you really keep. That's quite amazing. Yeah, thank you so much. I think Simranjit has a question. Simranjit, can you please unmute your microphone and quickly ask a question to Sonika? Yeah, please.
Hi, ma'am. Very good evening.
Hello.
First of all, ma'am, it was a very nice talk, very calmness and serenity. I could feel it during a whole talk. And I have a question. I will come to the straight the question that what is your views? I was talking about the cardiovascular vascular diseases. With respect to that, how about the antioxidants? So far, they have been like not so much given importance. Yes, they have also not like gone through the clinical trials. There have been problem with them, like H2O2, NAC, vitamin C. Yeah, ma'am.
Right. Thank you, Simranjit. Very interesting question, especially in view of the fact that there has been a complete shift towards how we view antioxidants pre and post COVID times. So, to any COVID patient, that the entire thing starts with the vitamin C and other antioxidant therapy. But before this, and to some extent, even now, I don't think we have seen antioxidant as a medicine per se. It is more of a preventive, immunity building, and overall good health strategy more than a drug. That has happened with antioxidants over a period of time. That's what I have perceived. But with COVID, we have seen that it has become part of the therapy.
Thank you very much, ma'am.
Wonderful, wonderful, Sonika. I hope Simranjit, that answered your question. Thank you so much, for asking this wonderful question. Yeah. Assuming that there are no questions, I'll probably ask Sonika to give her final comments if she has any questions or any points before we.
It was wonderful being here and interacting with all of you. And thanks for giving me a chance to come and connect and talk about it. Thank you.
Right. Thank you, Sonika. It's been absolutely fascinating, very inspirational, very motivational. As Simranjit, wonderfully puts it, the kind of serenity and calmness is always in this show. In the wonderful presentation that you already gave, which answered in all the questions. There were a couple of questions, which, in fact, the resistance asked, but those questions were already answered through your, wonderful presentation and slides.
I think we'll discuss more, and we will take many of our questions forward in future.
Yeah, no, very much, Sonika. In fact, we thought of having a women in biology, group discussion, which are women in biology core members. They will definitely invite you on this. But it's been absolutely fascinating, an amazing talk, and the wonderful opinions that you always put forth, the promising and the positive vibes that you have bestowed towards bioinformatics community, and the way that you have really passed on your baton to the next generation is quite amazing, Sonika. And thank you so much for obliging to our request in making it today for today's conversation. This has been the best conversation, and I'm sure many would probably want to have a click with you, a quick photograph with you. So I'd like to request all the participants over here, and the ones who are watching probably in YouTube, you'll be doing a miss. I'm sorry, but please, you can just switch on your cameras and have a quick photograph. Yeah, all of you, please, probably, yeah. I'm just setting it up. Yeah, setting the view.
Should I stop sharing the screen?
Yeah, you can do that. Yeah.
Yeah. Although you could take one click with our famous Netaji statue, where this is in our campus, and these are our students posing under it.
Yeah, wonderful. Yeah, this I've seen this, Sonika. Actually, this. But I'm sorry, I did not know that yours is a government institute.
It is.
Yeah. No, wonderful. Yeah. So friends, I think it is time all of us, start sharing our screen. And I'm sorry, I don't know why I'm not able to see gallery view. Yeah. So yes, everyone, Ranjit, Ritvik, Sundarda, Ayam, Renuka, Saira Sareen, you're going to miss a very good photograph. Yeah.
Hello, Renuka.
Yeah, Aparna.
Renuka is not here. I don't see her.
She is here. Maybe yeah. Yeah. Thank you, Anil. Yeah. Anshika. Yeah. A quick photograph. Yeah, please. Yeah. Yes. Say cheese. Yeah. Yes. Another one. Yeah. Yes. Aparna. Yeah. Yeah, it's pretty early for you, I know, but Aparna is based in Chile. Yeah.
Yeah.
Yeah. One photograph, please. Yeah. Thank you. Shazia. Yeah. Okay, good. Yeah. Thank you. Shazia is based in Turkey. Yeah. Wonderful. Yeah. Yes. Thank you. Thank you so much. Yeah. So friends, I think it's time we give a thumping round of applause. I'm giving a standing ovation to Sonika. She certainly deserves this wonderful this thing. Thank you so much. Yeah. Thank you, Sonika. Thank you so much. Thank you, everyone.
Thank you, madam, for nice talk.
Thank you. Very nice interacting.